Okay, and welcome to this video. We're looking at an algebraic technique in Factor 2, which involves the use of factor theorem, and this theorem will be useful for us in Pure 2, not only just to use long division, but also sketch cubic functions. So what is the factor theorem? Well, the factor theorem is actually something that you've been using for quite some time, but you just haven't been used to the word or the concept of a theorem. Essentially what it says is this: if you've got a number inside a function which makes the function equal to 0, then that implies that x minus that number is a factor of that function. And this double-headed arrow means this implication goes both ways. So a number inside a function which makes the function equal to 0 implies x minus a is a factor, but also x minus a being a factor implies that a would make the function equal to 0. This is something which you've seen at GCSE. If I think about a quadratic which has been factorized, let's say x minus 2, x plus 3, okay, then we know that the solutions are x equals 2 and x equals minus 3. And they are such because when you substitute in x equals 2 and x equals minus 3, then into the original function, okay, so x squared plus 3x, if you put 2 and minus 3 into the original function, that will make this function equal to 0. So we know this works, okay? Again, it can be used to solve equations in the form f of x equals 0 in exactly the same way as solving a quadratic equation. So let's have a look at question 1 here. So you're told that x plus 1 is a factor of this cubic. And given that's the situation, use a method of algebraic long division to factorize this fully and hence solve the equation. So they're telling us to use exactly algebraic division to factorize it fully and hence solve it. Now, algebraic division, if x plus 1 is a factor, that means when you put in minus 1 into the function, this whole thing is equal to 0. But to use algebraic division, we're going to have to treat this as such. Okay. Now, before we get into why we did, before we start doing this, let's understand why I'm doing this. Okay. So essentially, what I've got is, if I've got a situation, I've got a cubic. This cubic can be rewritten as x plus 1 and 2 other brackets. Okay. So whatever this cubic is, x cubed plus whatever, that can be rewritten as x plus 1, which is one factor, and two other brackets here. So to find these two other brackets, what I need to do is multiply both sides by x plus 1. Sorry, divide both sides by x plus 1, which is why I do the division here, because that will help me to get these two brackets. Okay, so I am physically dividing the cubic by this linear. Now, how do we do algebraic division at A level? It's much similar to just numerical division, which you do at GCSE. Again, you've got numbers that go in, but instead what we're really going to focus on is the algebra. So what I do is I look at x and I think, okay, how many times does x go into x cubed? I'll think to myself, x goes into x cubed, that will need to be x squared. And whatever I write on the top, I've got to multiply by these two things here to see if I have a remainder. So x squared times x is x cubed, x squared times 1 is x squared. When you subtract, you get 5x squared. And you've got to bring down the number here. Okay. Then you think about x into 5x squared. That's 5x. Again, you multiply these two by 5x. Okay. And you subtract and you're left with 6x plus 6. you bring this number down here. X into 6x is 6, and if you think about this, 6 times x plus 1 is 6x plus 6. When you subtract that, you get a remainder of 0, which is what we want, and that proves that x plus 1 is a factor because it doesn't give me any remainder. It does divide into the cubic. So that tells me this function, this cubic function, can be rewritten as x plus 1 and x squared plus 5x plus 6, which can be further factorized to x plus 3, x plus 2. Okay? And to solve the equation when it's equal to 0, make it equal to 0, x equals minus 1, minus 3, minus 2. Okay, so essentially what we've learnt to do is factorize a cubic. Okay, so you just use a linear factor and you use algebraic division. Work through this carefully. It's very easy to go wrong here. I would suggest putting things in line with each other. So you've got to bring things down. You know if something's a factor, and you know you've done the maths right when you've got 0 at the end if it's a factor. Okay, so that's how we deal with that. So question 2. Show that x minus 1 is a factor, hence show that has exactly one real root and state its value. So there's a variety of ways of showing that x minus 1 could be a factor. There's two ways we could do it. We could either do it by algebraic division and show the remainder is 0, or what we could do is substitute in x equals 1 and show that this would equal to 0. Okay, so what I'm going to do, I'm actually going to show both methods in this question. So I'm going to do the algebraic division so that at least I can recap this. So 2x cubed plus x squared plus 5x minus 8. Okay, x into 2x cubed is, sorry, let's write this in the proper place. I want everything to be aligned. 2x squared. That will give you 2x cubed minus 2x squared. 1 minus minus 2 is 3 plus 5x. Okay, x into 3x squared is 3x. So you get 3x squared minus 3x. So you get 8x plus minus 8. And clearly then we're left with 8. Okay, which shows remainder of 0, therefore x minus 1 is a factor. Okay, as I said, the other way of showing x minus 1 is a factor is substituting x equals 1. Two plus 1 plus 5 minus 8 equals 0, and you come to the same conclusion. Anyway, so we've shown that it's a factor from this method and this method, hence show that this function is equal to 0. When it's equal to 0, it has exactly one real root and state its value. Well, as I said, the function, which is a cubic, can be written as this linear function and this quadratic function. Now, if they're saying there's only one real root, then where have we seen that sort of statement before, one real root? Well, you can sort of think about quadratics. Okay, and if an equation, in this case we've got a quadratic equation here, if we can test how many roots this has, if this factorizes by applying the discriminant. So if we apply the discriminant on this quadratic, okay, so b squared minus 4ac, so 3 squared minus 4 times 2 times 8, 9 minus 64. Okay, and when you work that through, you should get 50 minus 55. Yep, minus 55, which shows clearly that there's no roots for the quadratic. So the only solution that we're left with, the only real root that we have is x equals 1. That is the only real root that we have. Okay, so just to recap, factor theorem. If you've got a factor which looks like x minus a, then the number a substituting the function will make it equal to 0, and likewise this number a, if it makes it equal to 0, will imply that x minus a is a factor. Okay, and we used a factor theorem to factorize a cubic fully in this example, because if you have something that's a factor and it factorizes it fully, then obviously you can divide by each of these factors to get the other two factors. Okay, so this is a very useful technique which we're going to work on later, but here's exercise 7c on page 145, well worth having a go at that.